it ain't had enough. I've had enough of running around this board game. You can know your own name. I won't give it up. Am I crazy? Am I foolish? Am I stupid for playing these games with you? If I told you I love you, would you say that it's fucked up? If I told you to fly in, would you say that you loved us? Don't take me for what I'm saying, just take me for what I am. 'Cause this is where I'm staying, my 2 feet are in the sand. I've been reading old shit, and I can't make sense of it. Ain't no conspiracy that can save me. Living in the moment feels good to me till it hurts, and I need somebody. Am I crazy? Am I foolish? Am I stupid for playing these games with you? If I told you I love you, would you say that it's fucked up? If I told you to fly in, would you say that you loved us? Don't take me for what I'm saying, just take me for what I am. 'Cause this is where I'm staying, my 2 feet are in the sand. Take me as I am, I'm tired of dancing around the point. Sharpen its jacket like the shape of glass, and it steals my voice. If I told you I love you, would you say that it's fucked up? If I told you to fly in, would you say that you loved us? Don't take me for what I'm saying, just take me for what I am. 'Cause this is where I'm staying, my 2 feet are in the sand. If I told you I loved you, would you say that it's fucked up? If I told you to fly in, would you say that you loved us? Don't take me for what I'm saying, just take me for what I am. 'Cause this is where I'm staying, my 2 feet are in the sand. Sometimes I sit and fantasize What more could I do? If love made what I feel for you, won't you say that you love me? For in your eyes I know this to be true. Swear that you flew the moment I held on to you. Why'd you let go of me when I know that you fall into? Just tell me you will never be, and tell me I'm too blind to see you don't love me. Let me hold you again. How can I be friends with this thing called consistency in your periphery is fear in the bridge of your nose. And as you move about, you learn to tune them out, but they say they continue to grow. Fear of the past and relative pain. Future's coming fast, you've got nothing in the tank. In a season of purging things you used to love, everything must go. Make an oath and make mistakes. Start a streak you're bound to break when darkness rolls on you. Push on through. Push on through. Then before you know, you lose some people close, forcing you to manage your pace. Found your capacity for love and tragedy, embracing how things always change.
You saw your chance to win with nice tactics and you took it.
Pain, little less concern when there's nothing in the tank.
Strong players throughout
in a
history
season
have played this game.
of
Gary
lessons
Kasparov,
learned in giving
Magnus
up.
Carlsen, Bobby Fischer, and you. Good thinking. Developing your knight protects the center and gets you closer to castling. You are losing a knight this way. Your opponent's move wins your knight. They missed a chance to win a knight through an eventual fork. Capturing your hanging pawn. Capturing your hanging pawn. Your better option was to castle kingside. You get a chance to checkmate the king. You missed an opportunity to checkmate the king. A correct move to get their bishop out of harm's way. You are now able to checkmate the king. You had an opportunity to checkmate the king. This move gives you the opportunity to win their queen. You missed an opportunity to checkmate the king. You had an opportunity to checkmate the king. You missed an opportunity to checkmate the king.
Caught myself calling you baby. Wish I could blame it on the wine. I'll say I'm okay with maybe, but I'm dying to say you're mine. Coming undone, here right now, crying out loud. Stay right here a little bit longer. Make it clear, I know that you feel it too. Why you putting me in this state of mind? Stay right here a little bit longer. Telling stories we both heard. All these nights that we've been through. Feel these lines getting so blurred. I bet heaven gets jealous of you. Coming undone, here right now, crying out loud. Stay right here a little bit longer. Make it clear, I know that you feel it too. Why you putting me in this state of mind? Stay right here a little bit longer. And I'll say I'm okay with maybe, but I'm dying to say you're mine. Stay right here a little bit longer. Make it clear, I know that you feel it too. Why you putting me in this state of mind? Stay right here a little bit longer. I can taste it on your mouth, and I can't leave it. You're a freak like me. Can't you see? We can work this something out, and I believe it. You get up on me. It's like cheating. I just wanna watch you take it off. Take off all your makeup, baby. Take it off. I just wanna watch you take it off. Take off all your clothes and watch you take them off. Take it off, baby, just take it off. Take it off, baby, just take it off. Me up against the wall, don't take it easy. You like it hard like me, it's what you need. Let's get naked and explore our inner secrets for what it is. It's what it is. I just wanna watch you take it off. Take off all your makeup, baby, take it off. I just wanna watch you take it off. Take off all your clothes and watch you take them off. Take it off, baby, just take it off. Take it off, baby, just take it off. Baby, just take it off. Take it off, baby, just take it off. I just can't wait to see it all. I'm so turned on, and it's all mine. I just can't wait to see it all. I'm so turned on. lose my head when you touch my leg. Can't help the way that I throw myself like a rhythm. I sit on the backseat, I'll stay at the party as long as you'll have me. I've still got my coat on, I'm getting my hopes up. I heard you like tall, so I'll stand on the phone. But I read online that you shouldn't change. Everybody's giving out advice these days, so I'll make an exception, 'cause I want you to want me, say you want me. Morning commute, I was thinking of you when I dressed myself. I was stressed like hell, 'cause you dress so well. Star sign conversation, truth is I tell a lie. I say I'm a Gemini, just so the stars align. You play with your necklace, I get a little restless, and I lose my head when you touch my leg. Can't help the way that I throw myself like a rhythm. I sit on the backseat, I'll stay at the party as long as you have me. I've still got my coat on, I'm getting my hopes up. I heard you like tall, so I'll stand on the phone. I read online that you shouldn't change. Everybody's giving out advice these days, so I'll make an exception, 'cause I want you to want me, say you want me. You said dive in the swimming pool, it feels so nice. Time escapes, then we're replaced by the waves that crash behind us and the memories that bind us to the past. Hey, not so fast, put a comma by the trauma. I don't know that I don't wanna. Should not give up, should not try, justify my own weakness, made my life a loneliness. Shouldn't I give up, shouldn't I try? No, I don't wanna think these thoughts tonight. Waiting all day to say nothing and fall apart. Don't cry, don't lie, don't sigh, don't mind, don't start. Crossed out names and games and stains, they've left a mark. Don't start. Get up, take off all your makeup, baby. I could cut my hands on your edges, but I won't pull away. You could shake your head back and forth and still fall down in beautiful refrain. I couldn't help but try to hold your hands wrapped around my face. It isn't hard to see, eyes closed, the love we made. you like the world, you danced around me like heaven. I don't wanna go home yet. When you asked, I got quiet. I know I should've just said it. Please don't go home yet. Stumbled up and down on my folly. Baby, I was just falling. Drawing every detail of your face, calligraphy I could trace. So help me God, I'll try to hold the hands wrapped around my face. It isn't hard to see, with eyes closed, the love we made. Oh, I spun around you like the world, you danced around me like heaven. I don't wanna go home yet. And when you asked, I got quiet. I know I should've just said it. Please don't go home yet. Please don't go home yet. Spun around you like the world, you danced around me like heaven. I don't wanna go home yet. When you asked, I got quiet. I know I should've just said it. Please don't go home.
Question marks and you're just surfing, leaning into me like it's an art. It's so crazy lately. You just understand my feelings, make me see I'm capable of flying and feeling beautified tonight. I'm ready to dive. Maybe it's the loving in your eyes.
no two people are the same. Stand beside you, but just far enough away. Last night we were drinking, try to think away the pain. Made that age-old mistake, tried to disconnect.
Baby, so
What time you coming out? We started losing light. I'll never make you right if you don't want me wrong. I'm so excited for the night. All we need's my bike and your enormous house. You said someday we might. When I'm closer to your height, till then we'll knock around on the sea. Don't you see me? I think I'm falling for you. Don't you need me? I think I'm falling for you. On this night, in this life, I think I'm falling for you. Maybe you change your mind. I think I'm falling. Call again. You said I know it's fine. I read between the lines and touch your leg again. I'll take you one day at a time. Soon you will be mine. Oh, but won't you know? When the smoke is in your eyes, you look so alive. Do you fancy sitting down with me, baby? Call into your
these longings locked in lowercase inside a vault. Someone told me there's no such thing as bad thoughts. Only your actions talk. These fatal fantasies, giving way to labor breath, taking all of me. We've already done it in my head. If it's make believe, why does it feel like? Hey girl, with your head in the clouds, I wanna love you, I wanna love you. Hey girl, trying to figure you out. I wanna know you, I wanna know you. Held her as close as the dress, pressed against my chest. I was seeing inside. Held her right in my left, trying to catch my breath, where the feelings are. Hey girl, with your head in
just
More.
yeah.
Yeah.
Biết khen cứu đó. Baby. Baby không á.
Okay đó. Vui quá, vui coi được.
Lấy cây cứ đừng đem bát thêm bị lại. Đừng nghe mà.
Do you any of your like kids have my size of what? Okay, size. Okay. I pack next time and give you.
Anh tìm nhà mắt.
Oh, nice.
Nhà mắt. Nè. Baby.
Oh, baby.
Baby.
Is it mommy?
Ông mâm đi.
Oh.
Đó. How are you?
Pack go jail.
Khang sẽ muốn làm phòng này nó khó.
2 months. 2 months.
Cái lớp nhiều này, lớp nhiều.
Nhưng mà
Yo, 2 months I moved there. Yeah. Yes.
cái nó chỉ cái xong là cái này làm này.
Thank you.
Thank you. Bye bye.
What size you wear?
Một.
Shoe size.
Size 40.
40.
40.
I ask and give you. I ask him
Yes.
because he two
How to
shoe.
how to shoot. Yes.
He go back.
Oh, okay. Thanks so much.
Thank you so much.
Moving to attempt 2. So what if let's not make rules, let's in सबके बाद भी we cannot literally make a system just based on rules which will be able to recognize a face. That is completely out of it is completely an impossible situation in this case. Moving to attempt 2. So what if let's not make rules, let's start with data. This is the part where machine learning as an idea first emerged. What if we give machines or computers a lot of data? It can, let's say, weather data or email data, and let it do statistical based learning, which means that the more the word appears, it sees what it is followed by or what it follows, and based on that it try to get a sense of what's really happening and what should I do in this situation. So we show these machines thousands or 100,000 of examples in a certain field or different fields, and what we expect them to do is that from this data, without us explicitly programming anything. So this is the field, like we are already into machine learning. Basically what machine learning is, we do not want to code or write stuff or write rules explicitly, but we want the machines to internally write rules for itself based on the data. This is the whole idea of machine learning. So let's say, we'll get to this later, but you get the idea of machine learning, right? We have a lot of data. We have to do a certain things. Let's say the way the data contains that 100 degrees Celsius hot weather. So whenever the machine sees that, the temperature is above a certain threshold, that means it's going to be a hot weather today, and all of that. If it is an email classifier, if we see like free money based on them, it is followed by some weird link, then it's definitely a spam. Or if it sees a meeting link with time and attendees names, it would consider that as an important thing, because based on statistics, we know that these things follow under these category, these things follow under these category. So we kind of make a bucket, and in there the AI puts the input based on the data we have trained it on. This was the idea which machine learning started on, and it is I think the definition of machine learning still today is making machines understand something without explicitly writing rules or typing code for it. Cool. So how does machine learn? We have gone, I think, a bit into it. We show machine example. Machine takes a random guess at start. We tell it if it's wrong, if it's right. It takes the feedback, adjusts itself, and repeat this process millions of times. By the end, we have something which is not as intelligent, but it has some sort of intelligence in it. You can call it intelligence, you cannot, but it has some sort of understanding of some words which are followed by something or not. So it would, based on this, I think at that time, this was a great achievement. So statistical models, I think, they were all the craze. I think Google were relying on them for a decade. So this idea really popped up and was used in industry a lot. Cool. So if we look at the whole, diagram of what AI is the ultimate goal, which is to make machines intelligent, under which falls machine learning, which is to learn from data and not write the rules and not do any of the stuff, or with as less as, I think, human involvement. So not just based on data, let's make machine learn. What is deep learning? Deep learning is a subset of machine learning which deals with neural networks. You might have heard this term a lot, that all the new models are based on something called neural network or transformer. These are I would say the smallest unit of these big systems. So that is basically a neuron. It is designed to mimic our human brain, where we have neurons which get fired up when we listen an action or see an action. Based on that, this field, the deep learning field, is the same thing, learning with data, but in here we explicitly rely on neural networks. Is this clear? I'll open the chat. Yeah. Chat is open, guys. Good, great. Let's continue. So we'll see what some of these early success was, which I just mentioned, that Google started to use statistical models a lot in their systems, and a lot of other enterprise-based solutions. So early ML was looking good. We all came from nasty rules and came up to something which we can learn from data. And I think the idea back then was that field by field we can apply this formula everywhere, and at the end we'll have a unified machine which is good in weather prediction, email classification, or destination planning, or all of that. So what worked was spam filter got better, recommendation system like Netflix, Amazon, Google search became better, image recognition became better, since we can look at some features of an image like distance between the eyes, the face, the mustache, if it's a cat. And based on that, we can easily classify something, not with great accuracy, but better than what we have before. And we are talking, not the 2000s, but before that. So this was still a popping field, and people got all excited for it that this one day would solve, all the agonies of human, and we'll end up with something better, something more practical. A machine likes ourselves, so we do not have to do the ugly work, and we can just sit and relax and make these machines better. But you can still see that this had some bottleneck. It cannot have a conversation with us since it's relying on rules, not rules. It's relying on statistical data. It cannot form its own sentences or articulate something for us. So that was not happening. It cannot understand if I'm writing something, because it is basically just saying, if I give it a whole paragraph, it would just see some keywords, and based on them, if it had seen them on the training data, if they were good in statistics and they were ranking high ranking keywords, they would understand that. Other than that, the whole paragraph would be left unattended. And also it couldn't recognize most of the objects for which we did not have enough data for, because I think we are talking about early 60s or 70s. Internet was just popping off. There was not a lot of data on the internet, so we had some issues with data. Again, these machines, still they are so dumb, they needed a lot of compute. Compute was not available back then. We had some bottlenecks. The field was plateaued after a bit of time, but people were really hopeful. They were raising a lot and betting on something which was not happening at that time. But if we see today, a lot of stuff has changed. So we'll see what happened. Why early ML was limited? I've already talked that there was not enough data, not enough compute. For deep training, computer needs, a lot of memory requirements, a lot of neurons to work on, a lot of multiplication they do in a mind, you can say. So we did not have that back then. There was no GPUs back then. We were training just on CPUs, which are not that fast or, efficient for this kind of mathematics. And the data was also a problem since internet just started up. We did not have these, big archives of stuff. So we were lacking a lot of things. The field was not making a lot of sense since data was the only thing we still rely on. But back then it was almost zero. So what happened? I think people lost all their hopes in machine learning, and AI winter strike. AI winter is basically that when the hope completely died in 70s, the first collapse happened. A lot of funding was pulled off from these different startup of companies which were trying to, make these statistical model better. Since there was no data, not enough money for compute, and not good compute was available at that time. The first collapse happened. People pulled out their money. There was a lot of buzz going around that it is a dying field. It would not last long, and everything was shut off. It was like almost dead. Other than that, some part of it was still working, which again busted because experts were backing off from it. The research was not getting anywhere. So everyone was like, okay, this is not working. This is not the right field to put our time on, and we should find something else which can, solve different stuff for humans. The field became a joke, so everyone was like, yeah, leave it. It doesn't matter. But if you look at today's scenario, or after 2012 or 2010, what happened is the internet has blown off. We have a lot of GIFs, videos, images on the internet. So you can see, and with that, a lot of text information on the internet. So you can see one of the major problems got solved. The data which we did not have back then is now available for free on the internet. GPUs came up, NVIDIA, you can say the market leader, was popping off, building these large GPUs for us, or for researchers, or for labs, or for companies, which can power these very minimal mathematical multiplications, but at a very fast speed. Researchers finally cracked deep learning. It started off with CNNs, neural networks working for images and all of that. So these three things happened and are still happening, which was the reason that the field is currently booming a lot. There's a lot of data in the market, which if at the current time, if we talk about, we can argue about it, that the data is almost over or not. But yeah, it's still an ongoing debate on that topic. But you can see from earlier 70s, 80s, a lot of problem is solved. We have the data, we have the compute, and we have the algorithms which can make machines intelligent. So we bet on it and see what happened. From now, I think we'll focus on language, as it was the first thing intelligence actually emerged on. Yeah, after the transformer, we can say it as and how it is for it's an for it, or it's more and that is that whole becomes as yeah, like computers are messy, ambiguous, and works with a lot of data. We cannot have a single system work for it. So this was we can simply just look at any sentence in the world and see that okay, I realize why it's so hard for a computer to understand language. Oh yeah, one fun thing. You guys might have seen the topic of today's Zoom webinar is fast tracking the AI course, for which some people got diverged and was like, okay, why are we doing fast tracking the AI course? Are we completing the AI course in one go or anything else? But what I actually asked, the person to create the webinar, I asked them to name it as the title as fast tracking the course of AI, which would basically mean that we're going through the how AI evolved over time. But they just replaced AI and put it in front, and that changed the sentence completely. It made the context so different that we were so confused. So you can simply see that if us humans can get so much confused with just a single word moving before two words, what about machines? They do not even understand what words are. Do we understand that? I'll open the chats. Great. I'll learn how to open a poll next time. Sorry. Great. Okay, so we are now working with languages because we understand how hard they are to work for computers. The field is known as NLP, which stands for Natural Language Processing. Like if you guys want to look up later after this lecture and understand more about NLP or languages or how intelligence work in languages, you can simply look at NLP, which basically starts from very history of how computers were, how languages was first seen, statistical models and all of that, n-grams models. But the field is known as NLP. Basically, NLP is natural language processing. We'll go thoroughly through 4 different aspects of it, like how it ended up on Transformer. But to start with, I think we can what if we just put up every word in the dictionary and make something for it, so the models understand that apple is a round fruit that grows on a tree and is red or green and has a crunchy or a crispy flesh. But the problem with this thing is, you can see the 2 examples here. Apple is a $1 trillion company. Apple is a fruit. Apple is a female record label. Everything changes with the context. Now this Apple is a $1 trillion company, and this Apple is not the same as the definition. It's completely different. So can you fit it in here? And can you see why it was hard to work with language? Because it completely changes with the context. Apple is a famous record label. Again, it is a name of a label, not a fruit. And in here, the model only knows about fruit. So the dictionary approach fails. We can simply see that. Next, we talk about statistical pattern, which worked for the very long time. I would say if a temperature is above X degrees Celsius, then it's hot, or it's not hot. It can basically understand this from a lot of data. If we pass it a lot of random text from the internet, it would see that if New is followed by York, and that makes up New York, it would end up learning that it is the name of a city, which ends up happening or coming up a lot. Sorry, there was a message. Yeah. So it will end up understanding that, okay, these words come so often, and most of the time they're referring to some kind of an event happening there, or some kind of elections happening there, some constituency changes, and all of that, and it would basically get on a conclusion that this is a city, and this would happen after a lot of examples, a lot of that learning loop. But this is based on just statistics, not anything. Google Translate uses this a lot. We can easily translate stuff based on statistics, because most of the stuff directly matches to different language based on the statistics, because the more the word appear in A language, the more the word appear in B language, and based on that we can compare any of these 2 different languages and put them, just based on the statistical mapping, change the order of the words and change the language of the sentence. Cool. So what happened was, we understand that words are very hard for machines to understand. They literally do not know that there's something in the world known as word, because they are just working with different pointers, different very low precision numbers, high precision numbers. So the words literally make no sense for them. So what if we can somehow transform these words or different tokens, I would say, into some kind of number? This was the first breakthrough. I would say the word2vec paper was the first thing to bring this to a wide audience, that we can transform words to different type of vectors. Vectors are basically just a list of different numbers. So you can see that in the square bracket, we have different random numbers, which are 0.92, minus 0.14, 0.005, etc. So what if we can transform all the different words into something like this? And in this case, what we are doing differently is that this apple would mean completely different for the fruit and would mean completely different for a company or a label, just based on these numbers. And how can we do that? Again, training on a lot of data, but how do we do that? But yeah, so how do we change these words into such numbers or a list of numbers? Basically, these are known as vectors. And again, we'll see that Apple, we do not just directly work with words, but with tokens. Tokens, you can for now understand them as full words. But if we go into like big models, they are a lot different. They can just be a single letter or, just 2 letters and all of that. They are based on different type of, like OpenAI have these tokens differently, Anthropic have them differently. Different companies follows different architecture or learning algorithm. And based on that, they have different vocabulary, and based on that, they have different tokens. But our goal today is to understand that how do we transform these words to numbers? That based on different type of, like OpenAI have these tokens differently, Anthropic have them differently. Different companies follows different architecture or learning algorithm. and based on that, they have different vocabulary. And based on that, they have different tokens. But our goal today is to understand that how do we transform these words to numbers. Yeah. Word embeddings. Basically, transforming any words to its vector form is known as converting them to an embedding. So in here, I've mentioned that the word apple is 0.9 minus 0.1, 0.05. What does it really mean to actually transform a word into something? What it means is that these numbers are different points in a very large space. So understand that we have this 2D space, like palm of like this, and the word apple, if it's 0.9, let's say it's somewhere here, then that means it's very high on this axis, which means that, let's say this name of this axis is red or color red. So we know that apple has red color. It would end up being very high on this axis, right? If we talk about shape, and let's say this is the square shape, we know that apple is definitely not square, so it would end up having a very low score. What this means is I've just talked in like 2D dimension, right? So this is in 100,000, like 64,000 or 128,000 different dimensions, and it can mean a lot of different stuff. But just to understand, you can just look at it that if the color is red, it is very high for an apple. If the shape is square, it is very low for an apple. And based on this, these different numbers represent different meanings in different dimensions. This is the easiest things you can guys, like each number represents a specific dimension, and each dimension represents a specific meaning. And these meanings change as the sentence continues to grow up. Cool, you get that? I'll see if again, I'll open the chat. Yeah, it's hard for you guys to come and chat again, but let me see. Let me just look at how to open a poll. कैसे रहता है? अरे तुम तो ऑडियंस हो भाई, अभी ऐसा माइक इज क्रिएटिंग इट, ये थोड़ा कम है, 90% इज गुड, 80 ऑफ फॉर्मेट, ओके. Okay, yeah. So again, I'll go what it means to change a word to a vector. Let's go to Excalibur and I'll show you. I think this would be a lot better. Let me move this here. Okay, so let's say the word apple. We have to transform this into a list of random, you can say 0.9 if the color is red, minus 0.01 if the shape is square, and a lot of different dimensions. Let's just talk about two over here. So what this means is, let's say we have this and this, okay. This basically means how red it is, and this basically means how square it is, right? So for an apple, if I ask you, like, where would it stand on this red axis? It would stand somewhere right here, right? Because an apple can be red or is red most of the time, can be green also, but let's just talk about an apple being red. And if I talk about different dimension, which is basically representing the square shape, what do you think will happen there? It would basically, be very low. This is 0 or 0.1 would somewhere be here. So this basically tells us that, the square shape does not align with apple that well, but the color red aligns so well with the apple. This was a very big breakthrough, because now for every word in based on the sentence, we can do different stuff. Let's say if it's a cat, we can have the same axis with an animal. Okay, if it is a cat, and if we have this axis of animals, and in there if we see if it's a cat or not, thus again the score will be very high, else the score will be very low if the image or the word is dog. So we understand that. Okay. So same thing is happening here for the word apple. 0.9 means red, so it is red. We know that the color of apple is red. Shape is square, that is not happening. Apple is not square, and that's how we can transform any word into a word embedding. So like now what we have is, instead of us passing just a word which is non-existent to a machine or a computer, we have something in form of number, and those numbers have meaning. So like these numbers are not completely useless, but they actually define what that word is composed of. And now this list of words, which we call a vector, can be passed down to a machine. So we have like a mapping between words and vectors, and these vectors can now be passed down to a computer, because computers work really well with these different numbers. Cool. So yeah, if we see here, we have 3 different words, king, queen, and apple, just to give you more, clarity on these, converting a word to an number. So if, let's say the dimension we are talking about is royalty, we know king is a royalty, queen is a royalty. The scores for them are 0.98, 0.97, which are like almost 100%. And the gender for, if we see, and here if the dimension is male gender, we know that the king is male, queen is female, so the score is very low for the queen. Edibility, like, is it something we can eat? Can we eat king? No, the score is definitely going to be low. Can we eat queen? No, the score is definitely going to be low. If we talk about apple in the same way, is it a royalty? No. Does it have a gender? No. Is it edible? Yes. So based on this, you can easily understand that any word can be transformed to a list of vectors, a list of numbers, and these numbers have different meanings in these very big dimension spaces. We are just talking about 2 dimensions or 3 dimensions, but in general, in practice, these are thousands of different dimensions. This is how we define a meaning or attach a meaning to the word using different numbers in different dimensions. I hope that is clear. Can we do a poll? Yeah, the score is much better now. Great. Let's move ahead. So we see that these words makes a lot of sense. We can easily convert them to numbers. Now comes the fun part. What can we do with this words being transformed to numbers? Like what happens now? We got the meaning of the word. But what can I do, right? मैंने ये सब कर लिया, अब मैं क्या करूँ? इससे फायदा क्या हुआ? So if we see that king and queen are placed assume this as a very big dimension space or n-dimensional space with difference of meaning each dimension is containing. But we are looking at a very simplified diagram of it or a simplified graph view of it. If you look at here, you can see king and queen are placed very close to each other. Man and woman are placed close to each other. And apple and orange are placed close to each other, but very apart from king and queen. But on the other hand, if you see, king and queen are placed very near to the man and woman. What this tells us is that similar words are close together. And if you can somehow see that the relations are also close together, that king is a man, and it's if you just move down in this dimension, right? If you just move down, if you just move down in this dimension, it would end up telling us that okay, this king is a man, and again, if you move it down in this direction, it would end up telling us that okay, queen is a woman. So we can say that based on this, the lower dimension or this arrow is the dimension of gender, and based on this, we can for any word, if we go down in this dimension, we can determine its gender. Cool. Okay. Yeah, let me clear these annotations. Okay, visualizing words. Again, we have put them close to each other. If you see, apple and orange are close together, car and bicycle are close together, cat and dog are close together because they are similar words. Cat and dog are animal, car and bicycle are vehicle, apple and orange are fruits. But if you see at the top here, we have Apple, which is in corporation. You can say it like, right, the Apple Corporation from which we have MacBooks, iPhone, etc. It is placed differently from everyone else because it is not closely related to any of these. Even though it is the same apple, you can see that this means completely different thing because this is the apple which is relevant to corporation. So this is how we can define different words, different meanings, and then these words can be transformed to different vectors. These vectors have a lot of numbers in them, and each number defines different meaning in different direction. It can be gender, it can be color, it can be shape, it can be size, it can be literally anything. There are like hundreds, thousands, or millions of the dimension, and we cannot really think about what kind of different meaning it is composed of. But we can simplify and understand that okay, this is how the stuff is happening in 2 dimensions or 3 dimensions. Cool. Okay, I already have talked about this. The magic of embeddings. Like we just saw that if we move down in a particular direction, we were ending up on learning about the gender of that particular word. The same is happening here. Let's say I know the vector for king, I know the vector for woman, I know the vector for man, and I know the vector for queen. So what we are doing here is known as word math. We have some word attached. We have some vectors or numbers attached to these different words. What they are really doing is that this king is something, it can have ABC vector. Like it can have a vector which contains ABC, same for man, same for woman, and same for queen. If you see what is happening here is king minus man. If you think about what's happening here, they're minusing or they're subtracting the gender and removing the gender man. And what they're doing is adding the gender woman. So what happens if you remove the gender king from, if you remove the gender man from a king and add woman to it? You can see we end up having queen, and that is very fundamental or easy thing to understand. Same goes here. If we have Paris and if we remove France from it and add Italy to it, what's happening here? We are removing the capital and adding a different stuff to it, and it would end up giving us the capital of that stuff we have added. If we are walking and remove walk from it and add swim, but we end up having swimming. This is word math, and it literally opened a lot of doors in the field of AI or in the field of machine learning. Because with this simple calculations, we can understand different meanings for the words which we have not even trained on. And just based on these very high dimensional, matrices or graphs, etc., we can easily end up learning a completely new different dimension, which was not even in the training set, and it would end up teaching us a lot more than what we have trained on. Cool. Again, we are still, having this one single problem. If you look at these 2 sentences, I went to the bank to deposit the cash and I sat on the bank of the river. The word is same here. Each word has, a single vector attached to it. But these vectors are not talking to each other, or these different vectors like sat vector, on vector, da vector, do not know about each other, or if they are used, together, or if they are not together, they do not know about them. They just know that, okay, I am went, I am bank, and this is what bank means. And yeah, just that. It would not be able to understand that in these 2 cases, bank is completely different thing. So we can see that we have solved a lot of problems. We can understand, we can teach machines at least what a word is, or what a single alphabet is, or what it comprised of. And somehow we have given it some sense of understanding that, okay, we are making some progress, but okay, in sentences, this still does not work. It's good to classify different words, good to classify different genders or anything like that. But when it comes to, talking, conversation or sentences, it is not working that well because it does not know what word it came before or what it came after. Even if it knows that, let's say, it would not, completely understand that, okay, what if I comes before a river? Let's say bank is coming before a river. Okay, I'm coming, but then मेरे को फर्क नहीं पड़ता. Bank कह सकता है ऐसा if it's just because bank is just a single meaning, a single vector, and river is just another single vector. It doesn't make sense for them to correlate without us doing anything, right? Makes complete sense. So the idea is to process the whole sequence. If I have the whole sentence, I would process hi, my name is Rishabh, and all of these would be processed in the sequence. This was the first idea. Research started on it. The model or the area of this research is known as sequence models. It it has different kind of stuff like RNNs, LSTMs, GRUs, and then we can also list down transformer as a sequence model, which is the most advanced stuff that has happened yet. There are other divergent fields like Mambas and etc. But those did not really scale well or had a good effect on the overall enterprises or general public. So we are basically RNNs, LSTMs, and these stuff. We'll enter transformer. I would say with some of the intuition from sequence model. But before we start, let's just do another poll to see if everyone's catching up with it. Okay, let's go back a few slides and start that. Okay, so I assume we easily understand that from the last poll that, okay, close words are related closely and different words are not very close to each other, but somehow the meaning is contained. And if we move down or if we move, in a certain direction or a certain way, we end up on a different word. And that dimension is basically a meaning which we are moving towards. So like, again, let me annotate. So let's say I have this king, and if I move down from here, I'm ending up on man. What does this tell me? That king is somehow related to man. And we know that this relation, we can name it as gender, right? Because man is a gender and we know king is a man. So this dimension we can refer to as gender. Again, we cannot, based on the single point, we cannot explicitly say that. But again, we can see that queen, if we move down in that same dimension with the same amount of data or the same amount of length, right? We are ending up on woman. What does that tell us? That these words, without explicitly trained on something, just trained on data, retain knowledge that tells them, okay, close words stay close, related, word relationship stays close, but different words like car and bicycle are not related to king and queen. They can be in very long dimension as their vehicle or stuff like that, but right now they are not. So this dimension tells us about gender. We can do similar things for like cat and dog and different stuff and different kind of mathematics for it. So this tells us something like that. Again, if I show you, like, let me clear these drawings first. Yeah. Again, if I show you these examples, let's look at them again. King minus man. What am I doing here? If I remove king, if I remove man from king, what is removing here? We are removing the gender, right? And if I add woman to it, what are we adding to it? We are adding gender, right? So we remove the gender male and added the gender female to king. What is king? King is a royalty, right? King and queen are royalties. If I removed removed male and added female to this king royalty, what does it end up? It ends up on queen. That's very intuitive, right? We are just doing basic addition and subtraction. Again, for capital and cities, capital and countries. From Paris, I'm removing France and adding Italy. So what is happening here? We're removing capitals and adding different country. What would happen here is basically, it's like India minus Delhi plus Bangladesh. What would that end up on? It would end up on Dhaka, right? Because that's the capital of Bangladesh. And these words with the meaning of these different dimensions we've talked about somehow compose the meaning of these capital cities or countries. And when they are subtracting from each other, they move in complete different direction. So like this is king. If I minus man from it, it would remove this vertical axis we saw that, which was gender, right? And it would remove that. And then we are adding woman to it. It would add the female gender to it. So what is basically happening is we are removing male and adding female. And in what we are adding it is basically king. King is a royalty. And we know the female of king is queen. So that's how we do the word math. I think this should now be understandable. Can we do the poll again? And that's a full now. Then comes the DC derived from the different numbers we learned about is being added. So what ends up happening is we somehow end up on a completely different vectors in both these cases. And we solve a problem because what the problem here was that both in दोनों banks के लिए हमारे पास एक ही वेक्टर था. But अब ये दोनों जो वेक्टर हमें मिले हैं finally sequence models में जब हमने single words process किए, these both are completely different. So now we will not have the same problem which we had here as bank being referred to the same bank, which is the place we put money in, but is referred to as completely different things in both these sentences. Do we understand that? Let me open up a poll. Now I know how to do it. All right, no, relaunch poll. Yeah. Let's see that again. I see it's 80%. Let's get that better. Oof. Let me open up a poll. Now I know how to do it. All right, no. Relaunch poll. Yeah. Let's see that again. I see it's 80%. Let's get that better. Oof. We understand what a word is, like the meaning of how we are making a simple word into different numbers, let's say, which is a vector. So what we can do is, if you see this sentence, and what would happen here is, when the word bank appears in both these sentences, it would have the same meaning, right? Because it has a single vector, which means the place you put money in. But if you look at both these sentences, in first the bank means that, okay, that's great, but in the second the bank means the side of the river, and that's completely different thing. So how can we solve this? What if this specific bank जो word है, इसे पता होता कि इसके आगे river है, या इसके आगे cash या पैसों की बात हुई है. So it would basically understand that अगर पैसों की बात हुई है तो भाई bank होना है, the place you deposit money or withdraw money from, and if river की बात हुई है, oh, this is not the bank which I understand, this is the side of the river. This would happen, right? And how can we do that? Basically, what if we word by word sequence को प्रोसेस करें? That's sequence models. सबसे पहले in this case I को प्रोसेस किया, when को प्रोसेस किया, to को प्रोसेस किया, da को प्रोसेस किया, bank को प्रोसेस किया. अब तक दोनों सेम थे, okay, लग भी सेम रहे हैं. The change happened when the word like deposit comes, deposit का ऐड किया, cash का ऐड किया, और इसमें river का ऐड किया. जब हमें फाइनली दोनों का वेक्टर मिला, अब तो बिल्कुल अलग होगा. पहले तो दोनों का बैंक सेम लग रहा था and it might get confused. But जब cash की बात आई, पैसों की बात आई, तब इस बैंक का मतलब कुछ और है. But जब river की बात आई, the vector would mean completely different from what it meaning in the above sentence, right? This is how the origin of sequence models came in, and we call them recurrent neural networks. So basically, there's a concept of recurrent here because we are moving, and the sequence have in the architecture we'll see that what's recurrent meaning here. But this basically is an architecture which is based on neural networks. We know that neural networks are the field which deals with deep learning. So now we are learning deep learning, learning about deep learning. So these RNNs, what they do is basically word by word process something, and from each word they maintain some memory. So for this one, I talked about this sentence, right? For each of these words, they would make a memory of the previous words or the previous sequence what has happened till now. So if you see till here, both of them would be quite similar. But as soon as the words like पैसों की बात आई, जमा करने की निकालने की बात आई, account की बात आई, it would be completely different. And इसमें river की बात आई, it would be completely different. So this is how the context, or, the upcoming words in a sentence changes the meaning of a word completely. Now do we understand it? Relaunch poll. Cool. Great. It's 95. Why is it stuck? Yeah. You understand what sequence models are. We have passed one step. You guys know what deep learning is. That's great. Great learning for today. But you can easily see that sentence बड़े होते जाएंगे, पैराग्राफ बड़े होते जाएंगे, स्टोरी बड़ी होती जाएगी. कितना याद रख पाओगे, कितना वेक्टर चेंज कर लोगे तुम? This is an everlasting problem that of memory, right? तुम कितना ही लंबा सेंटेंस याद रख लोगे, कितनी चीजें याद रख लोगे. There will be a time when stuff completely messes up and blows your whole architecture, blows your whole model. So in this sentence, the cat which was sitting on the mat that I bought from the store near the old church on the corner was happy. जब तक हमारा सीक्वेंस मॉडल जोर पे आ रहा है, तब तक वो भूल ही गया भाई कि मेरा सब्जेक्ट क्या था, मैं इंसान की बात कर रहा था, मैं बिल्ली की बात कर रहा था, कुत्ते की बात कर रहा था, किसकी बात कर रहा था. क्योंकि the problem is forgetting. वो कितने ही वेक्टर्स याद रख लेगा, कितने ही वेक्टर्स ऐड करके याद रख लेगा, the meaning would completely disrupt by the time it ends up coming on boards. And this happens in all the big sentences. For small sentences, RNNs work really good, or for small cases, like if you talk about very large chunks of data, the thing we can simply pass 1,000 lines or 2,000 lines stuff into ChatGPT and it would still understand something, or most of it completely. But the same was not true for RNNs because ये तो हर एक चीज याद कर रहे हैं ना, not the transformers. Transformers अलग करते हैं. तो जैसे तो the cat was sitting from cat mat store etc. सब याद रखना पड़ेगा. और जब तक ये पहुंचेगा कि was happy, अब happy कौन था इसे क्या पता? क्योंकि the first word which came, that was the subject ना, उसकी बात हो रही थी. But at the end of the sentence, it is now looking back at the history, which is completely messed up. So it doesn't really understand what's happening in the sentence, and that's end up not giving you the best answer. Do you understand the problem? Let me open the poll. I think this is pretty clear. Great. Wait, 90%. I'll take it as a yes. But again, एक बार फिर से बता देता हूँ. The cat which was sitting on the mat I bought. अगर तुम सेंटेंस पढ़ोगे, you can easily say that okay भाई cat कुछ भी ना मेरी, क्योंकि उसने नया मैट लिया. बट RNNs को नहीं पता है, क्योंकि वो तो हर वर्ड को इंडिविजुअली प्रोसेस कर रहा है कि कैट थी, मैट पे बैठी थी, जो मैंने बाजार से लिया था और वो खुश थी. ये मेरे को तो आसानी से समझ आ गया. You guys can easily understand it too. बट मॉडल मेरा RNN तो नहीं, क्योंकि हर एक वर्ड को प्रोसेस कर रहा है वो. हर एक वर्ड को प्रोसेस करने के बाद उसके वेक्टर पे जा रहा है और हर एक वर्ड को प्रोसेस करने के बाद पिछले वेक्टर से कुछ ला रहा है. हर बार कुछ ना कुछ तो मीनिंग और इन्फॉर्मेशन गायब होगी हर स्टेप पे. एंड द इन्फॉर्मेशन लॉस बिकम सो बिग एट द एंड कि बाद में उसे पता ही नहीं कि भाई बात किसकी हो रही थी. राइट. The thing with this, you can see we are moving in a very linear fashion. Like this is a sentence we are moving like this, and by the time we are here, we do not know what happened, at the start of the sentence. So this was the problem, and this is the problem is basically forgetting. It would forget a lot of stuff, it would forget, but the subject is, but the verb is what I'm talking about. क्योंकि मेरी मेमोरी इतनी है ही नहीं कि मैं इतनी चीजें याद रख लूँ. और है भी तो वो इतनी मैसी होगी कि उसे रिट्रीव करना इन्फॉर्मेशन बहुत मुश्किल होगा. तो हमारे पास 4 चीजें हैं 2012 के बाद से कि हमें पता है कि वर्ड्स को कैसे समझे, हर सेंटेंस को कैसे समझे वर्ड बाय वर्ड करके, क्योंकि इसमें मेमोरी याद करते जाएंगे. बट हमें ये भी पता है कि वो भी फेल हो जाएगा कि फॉरगेट तो मैं कर दूंगा, कितनी चीजें याद रख लूंगा. हमारे पास बहुत सारा डेटा भी है, हमारे पास बहुत सारा जीपीयूज भी है. द फील वाज स्टक हियर फॉर a lot of stuff was happening. Like something RNNs के बाद LSTM साइड उन्होंने क्या किया कि एक अलग से गेट लगा दिया कि द कैट वेट, जैसे विच का आया, विच कोई इंपॉर्टेंट शब्द नहीं है, इंपॉर्टेंट वर्ड नहीं है सेंटेंस में. तो मॉडल के पास ऑप्शन था कि क्या मुझे याद रखना है, क्या मुझे याद नहीं रखना. तो ऐसे हर वर्ड पे उसे गेट लगा दिया कि या तो मैं याद रखूंगा या तो मैं याद नहीं रखूंगा. दैट वाज द थिंग वी डिड विद LSTMs. LSTM are long short term memory models which came after RNNs, and the only thing which they improved on was adding a gate that like on each word it would have an choice to either remember it or add it to its memory or not. So इस केस में वो क्या हो सकता था कि विच पे भाई वो बोलेगा मेरे को नहीं याद रखना, वो पे मेरे को बोलेगा नहीं याद रखना, सिटिंग पे बोलेगा हाँ मेरे को याद रखना, मैट बोलेगा हाँ मेरे को याद रखना है, और बहुत हैप्पी पे बोलेगा मेरे को याद रखना है, कैट पे बोलेगा मेरे को याद रखना है. तो इस केस में क्या होगा कि जो मेमोरी और जो इन्फॉर्मेशन उसे रिटेन करनी थी वो सरप्राइजिंगली बहुत कम हो गई है. राइट. क्योंकि हाफ ऑफ द वर्ड्स या उससे ज्यादा उसने याद रखने की कोशिश नहीं की, कि दे वर नॉट मेकिंग एनी सेंस फॉर इट टू रिमेंबर एंड वर्क ऑन देम और प्रोसेस इट. राइट. That's what happened with LSTMs and then GRUs came. But still, the RNNs failed at the sentence. If we, bring a 10 times longer sentence, the same would happen with LSTMs. Because at the end, what they're doing is they're making understand it. उनके पास एक डब्बा है, उसमें वो इन्फॉर्मेशन डालते जा रहे हैं हर वर्ड की. RNNs ने क्या किया, इस सेंटेंस में सबकी डाली, उसका डब्बा भर गया. LSTMs क्या करेंगे भाई, सिलेक्टिवली डालेंगे. बट इसके 10 गुना बड़ा सेंटेंस आ गया तो सिलेक्टिवली इन्फॉर्मेशन इतनी बड़ी हो जाएगी कि उसमें भी डब्बा भर जाएगा. तो डू वी अंडरस्टैंड दैट कि हमारे डू वी अंडरस्टैंड दिस 4 थिंग्स की वर्ड एम्बेडिंग्स क्या है, कि हर वर्ड को मतलब हम एक वर्ड को कैसे मीनिंगफुल बनाएं एक मशीन के लिए बाय टर्निंग देम इनटू नंबर्स और वेक्टर्स. सीक्वेंस मॉडल्स क्या है कि हम सेंटेंस को कैसे प्रोसेस करें, एंड वो क्या है कि LSTMs क्या है बेसिकली जस्ट अ गेट की याद रखो या नहीं. एंड वी अंडरस्टैंड द प्रॉब्लम दे हैव. राइट. कि इन्फॉर्मेशन में कितनी ही स्टोर कर पाऊंगा. Cool. Do we understand these 2 things? And then we already understand that we have a lot of data by 2017 or 2015 and a lot of powerful GPUs. So are we clear on these 4 things? Let me reopen the poll. Cool. Yeah, 90%. That's great. Very nice. Okay, let's move ahead. The idea of transformer. It's very interesting. Let's see what do you think can, like, हमारे पास एक ही चीज बची है सोल्व करने को कि हम चीजें भूले ना. और उसके लिए हम बेस्ट चीज क्या कर सकते हैं कि बहुत ही ज्यादा सेलेक्टिव हो जाएं कि एक वर्ड के लिए मैं दूसरे, क्योंकि एक सेंटेंस में इफ यू रियली लुक एट इट देयर आर ओनली 2 or 3 वर्ड्स व्हिच मेक द फुल सेंस फॉर इट. लाइक अगर हम पिछले वाले सेंटेंस में भी जाएं, लाइक इस वाले में एक बैंक वर्ड है और अगर मैं सिर्फ कैश वर्ड भी देख लूं ना तो भी मेरे को पता चल जाएगा कि ये बैंक कौन सा है. और अगर मैं रिवर वर्ड भी देख लूं तो भी मेरे को पता चल जाएगा कि ये बैंक कौन सा है. और इन दोनों केसेस में दूसरे बैंक है. सो लाइक वी डू नॉट नीड टू learn about the whole sentence, or we do not even learn about a good part of that whole sentence. But basically these 2 or 3 words अगर हमने ढंग से देख लिए और रिटेन कर लिए जब हमसे कोई पूछ रहा है दोबारा, then that's a very good thing because we use as less as memory we can and we got the best outcome out of it. Right. This was the whole, मतलब यही चीज हमें सोल्व करनी है जो कि प्रॉब्लम थी सीक्वेंस मॉडल्स में अभी तक. राइट. So what was happening in sequential model or RNNs or LSTMs I would say कि हम एक लीनियर फैशन में मूव कर रहे थे. ये मेरा पहला वर्ड है, ये मेरा लास्ट वर्ड है, इसमें ऐसे प्रोसेस करते जाएंगे हर वर्ड को. बीच में मेरे को गेट लगा दूंगा LSTMs में कि याद रखना है नहीं रखना, बट हम मूव तो ऐसे ही कर रहे हैं. इससे 2 चीजें हो रही है. एक तो जब तक ये वाला पहला वर्ड प्रोसेस नहीं हो जाता हम दूसरा वर्ड प्रोसेस नहीं कर सकते या फिर तीसरा वर्ड प्रोसेस नहीं कर सकते. तो एक तो सबसे पहले स्पीड बहुत कम है हमारी, और दूसरी वही बात आ गई कि मेमोरी तो इसमें है ही बेकार. So yeah, you can look at it. The same thing is mentioned in the slide. These models were sequential. एक वर्ड प्रोसेस कर रहे थे. मान लो बुक के हर वर्ड को स्टार्ट टू फिनिश रीड कर रहे थे. बट डू वी डू दैट एज अ ह्यूमन? हम तो बेसिकली पूरे सेंटेंस को जस्ट स्किम थ्रू आवर आईज एंड वी जस्ट रिटेन द बेस्ट नॉलेज वी कैन. लाइक कैरेक्टर का नाम क्या है, अब उसने इफ इट्स अ विलन और इफ इट्स अ हीरो एंड इफ दे आर कमिटिंग अ क्राइम और सेविंग समथिंग, वी जस्ट स्किम थ्रू द फर्स्ट पेज और सेकंड पेज ऑफ द बुक एंड अंडरस्टैंड मोस्ट ऑफ इट, व्हिच द मॉडल्स कैन नॉट, बिकॉज़ these models we are talking about earlier sequence model, क्योंकि वो तो एक वर्ड प्रोसेस कर रहे हैं, एक तो पढ़ेंगे भी धीरे और रिटेन भी कुछ नहीं कर पाएंगे. डू यू अंडरस्टैंड दैट? नया तरीका क्या है? क्या कैन वी मेक एन आर्किटेक्चर, कैन वी मेक समथिंग लाइक हर एक वर्ड पे वी कैन प्रोसेस इंडिपेंडेंटली, कि मैं आई पे भी साथ में प्रोसेस कर रहा हूँ, एम पे भी, माय नेम इज ऋषभ, सब पे एक साथ प्रोसेस कर रहा हूँ. बाद में जाके मैं इन्फॉर्मेशन मिला रहा हूँ और आपस में उन्हें कोरिलेट करा रहा हूँ समहाउ, एंड देन आई एम गेटिंग द बेस्ट आउटपुट. क्योंकि इससे क्या होगा, एक तो मेरा वो सीक्वेंशियल मॉडल हट गया और हम पैरेलल हो गए कि एक साथ 3 वर्ड्स पे, एक साथ 1000 वर्ड्स पे ध्यान दे सकते हैं. और उसके बाद दूसरी चीज क्या हुई, अब इन पूरे सेंटेंस में हमें 2 ही चीज को तो याद रखना है कि बैंक है तो कैश है या रिवर है. अगर इन दोनों में से मैंने एक भी चीज पकड़ ली तो इजीली मैं क्लासिफाई कर पाऊंगा एक बैंक कौन से बैंक की बात हो रही है. राइट. तो दिस इज व्हाट द होल आइडिया ऑफ ट्रांसफॉर्मर इज. द फर्स्ट थिंग इज वी मेक द आर्किटेक्चर पैरेलल, कि हर वर्ड इंडिपेंडेंटली प्रोसेस हो, अगले पिछले वर्ड का वेट ना करें. एंड द थिंग अबाउट व्हिच आई एम टॉकिंग अबाउट कि 1-2 वर्ड याद रखनी है, 1-2 वर्ड्स याद रखने, उसे पूरा सेंटेंस का मीनिंग जानने के लिए, उस सीक्रेट को हम कहते हैं अटेंशन. Attention is something which the model attends to relevant words no matter how far apart they are. Right. Like if we go back to the last slide in here, अगर मेरे मॉडल एक तो सबसे पहले इन सारे वर्ड को वो इंडिविजुअली प्रोसेस करेगा एक साथ. राइट. तो सबसे पहले स्पीड तो बहुत ही ज्यादा फास्ट हो गई. उसके बाद दूसरी चीज वो क्या करेगा कि जब हैप्पी की वॉज हैप्पी की बात हो रही है उसके बाद देखेगा कैट की बात हुई थी बस स्टार्टिंग में, बीच वाला कुछ मैटर ही नहीं करता। अगर मेरा उससे क्वेश्चन है कि हु वाज हैप्पी, इट वुड इंस्टेंटली टेल मी दैट द कैट वाज हैप्पी, क्योंकि उसने मोस्ट रेलेवेंट सेंटेंस और मोस्ट रेलेवेंट वर्ड पिक कर लिया उस सेंटेंस से। सो डू वी गेट दैट? आई विल ओपन द पोल, लेट मी डू दैट। ओके, या इट्स अ बिट 80%ish। ओके, we'll see that again। हमें ये तो समझ आ गया कि सीक्वेंस मॉडल में हम एक एक वर्ड करके जा रहे हैं। आरएनएन्स में हम सब कुछ सारी चीज़ों की हिस्ट्री और मेमोरी याद रख रहे थे, एलएसटीएम्स में हमने सेलेक्टिव कर दी। अब हमें इससे आगे बढ़ने के लिए क्या करना है भाई, हमें और भी ज़्यादा सेलेक्टिव करनी है, राइट? क्योंकि इस पूरे सेंटेंस में अगर वो सिटिंग, मैट, बोर्ड, फ्रॉम द स्टोर को भी याद रख रहा था तो भी इट वाज समहाउ वेस्टिंग, राइट? क्योंकि इस पूरे सेंटेंस में अगर वो सिटिंग, मैट, बोर्ड, फ्रॉम द स्टोर को भी याद रख रहा था तो भी इट वाज समहाउ वेस्टिंग दैट इन्फॉर्मेशन, क्योंकि वो तो यूज नहीं है मेरे फाइनल क्वेश्चन को आंसर करने के लिए, राइट? कि मेरा क्वेश्चन तो था हु वाज हैप्पी। अब उसमें मैट, कैट कहां से मैंने खरीदा, मैट खरीदा, क्या खरीदा, क्वेश्चन तो ये था खुश कौन था, खुश तो बिल्ली थी मेरी, इसके लिए मैट आया। अटेंशन डज दिस, ट्रांसफॉर्मर डज दिस। ट्रांसफॉर्मर सबसे पहली चीज तो क्या करता है, जस्ट अ मिनट, yeah, so what was happening in sequence model was that we were going word by word. Each of these words have different meanings, and we were in RNNs we were just storing all of them into something we call as memory or history. And usse, from that we were able to understand how the earlier words or the next words are going to behave. LSTMs was just that we applied a gate on every word. We have a gate which is like on which it would ask that should I remember this or should I not remember this. LSTMs would say which ka main, what would I do of which ka main kya hi karunga, remove that, I don't need the information of that, right? Same would happen for the all of the other words, and it might retain obtain something like sitting, mat, board, store, church, corner, and happy. So the information stored by LSTM cell even before him which is on the cat, right? All the other information of the sentence is worthless. कोई काम की नहीं है, right? क्योंकि my question is just valid for that single word. Now do we get that? Great, yeah. I think that's better, 90%. Just to recap, sequence model, we were going word by word. एक अगर हम word से जा रहे हैं, it would definitely be slow. First of that, we solve that. Let's now process each word individually. कि जितना word एक time को process करने में लग रहा था, अब उसमें in that same time I can now process all of the words simultaneously. We solve first thing, speed. Second thing, what we have to solve is we have to select most relevant stuff, like the ultimate or the. We have to make it just like our brain. If I am as a human, I'm reading that sentence and someone asks me who was happy, my word without any thought would say the cat was happy, right? We want that same relevance from our model. That's what attention do. Attention gives me that most relevant word my question would relate to. And this is what was added to transformer. These two things alone made that a breakthrough. What happened was, now we can do stuff so fast, we can read so much of information. We already had a lot of data, we can train on a lot of data. And with that, the addition of attention. Now we do not care about memory. It can be as long as it won't. We have some implications of it that models forget, even like ChatGPT and all. But they are 1,000 or a million times better than RNN and LSTMs. We'll talk about those implications a lot later. But for now, let's understand they have infinite memory, right? Because they are only attending or giving me the most relevant words for every question I ask. Cool. This is the secret attention. We'll see it more in depth when we cover it later in the whole transformer architecture, and we will code it out too, so you guys can get a lot of information. But in today's class, that agenda is you understand what happened before, what is happening now, what transformer is, what it evolved. So if I ask you the question, what transformer added? Two things, right? It made it fast. It made it attend to most relevant stuff. These are the two things it done. Fast, how? Most relevant. More the same. That attention phase. थका हुआ कौन था? We would simply say animal. सोचने की जरूरत भी नहीं पड़ी. We didn't even need to think, right? That's what attention is enabling. Relevance I get parameters. Pass to transformer again. The next word comes. If we go back, we pass an input. Rishabh is just that to the transformer. The only thing transformer can do is just predict the next word. It predicts this from a list of different words and outputs. So we can either choose the lowest probability one, which can be gibberish or can be girl. But for now, we are choosing the most highest probability of the word that can come next, which is right now boy. So we get the output. Rishabh is a boy. But you see, in ChatGPT, what happens is you get a lot bigger sentence. How does that happen? If you're like, I'm saying that it only predicts one word, right, to the given sentence or the given input, but the ChatGPT answers in a lot more words. How does that happen? That happens via this. This word is again then passed to transformer. Like here, if I put it, yeah. This word is now passed to transformer. But now what would it do now? That it would again pass through everything, do the attention thing, do the processing thing, and it would again give me a list of list of words that can come. Let's say in this time it gives me a full stop. It is very good. 80%. Okay. We'll see once again. Let me open ChatGPT and show you guys what it answers. Rishabh is this is what I input. Let's see. Now ChatGPT has a lot of stuff, like it has information. Look at this thing. What it output? Let me put it up. Looks like the sentence got cut off. The model is so smart now that it knows the sentence got cut off. But if I ask it again, Rishabh is complete this sentence. Now we have to give it explicit information to process it, because the models are so smart that they understand that okay, something might have happened because the sentence looked like it cut off. See, it gave us so many different words, which is not just a single word. मैंने तो अभी बताया ना कि transformers can do only one thing. They can just predict the next word given a sentence or given a sequence of words. They can only predict the next word. So in here, let's see, Rishabh is a curious and driven individual. What is really happening here, if we go back, is that Rishabh is a transformer ChatGPT ने process किया. उसका एक list of factors उसे output मिला. उसमें था curious सबसे ऊपर. Like the most probability of a word to come ahead of Rishabh was curious. So the word it outputted or gave as an output on the first turn was Rishabh is a curious. ठीक है, the word अभी भी sentence complete नहीं हुआ, ChatGPT ने तो और ज़्यादा आंसर किया है. What happens is, as soon as this happens, it get passed to transformer again. The next word comes. If you go back and look at Rishabh is a curious and this was the next word it generated. What would happen now? This Rishabh is a curious and this whole thing would again get passed. It happens so fast. Like I just typed this in front of you and it has given me a lot of words. I'm explaining it like it happens in a long time. No, because the first thing we learned about transformer, it processes all the information parallelly. And a lot of stuff has happened after that, which has improved the speed a lot. But that's the first thing. Key information it processes parallelly, and that allows it to perform or work very fast. So Rishabh is सबसे पहला word it generated curious. Again the whole sentence got into transformer. The next word came, and again the whole sentence got into transformer or ChatGPT. Then the next word it output was driven. सबसे ज़्यादा probability उसकी होगी उस list में जो उसने output की. उसके बाद again this Rishabh is curious and driven. Again pass to the transformer, goes through the transformer, all the attention stuff, outputs a list. उसमें सबसे top पे कौन होगा? Driven में आया sentence में add हुआ. Against this sentence it just created is passed on to transformer. फिर से एक लिस्ट ऑफ वर्ड्स मिले, उसमें सबसे ज्यादा प्रोबेबिलिटी लेट्स से इंडिविजुअल की इस बार, तो सेंटेंस में सबसे आगे हमने इंडिविजुअल जोड़ दिया. दिस इज हाउ द होल प्रोसेस ऑफ लैंग्वेज जनरेशन डज. दिस इज व्हाट ChatGPT is doing behind. As soon as you type something, it is going somewhere in some server where a model is working, and in there Rishabh is get processed. उसके बाद अगला वर्ड it generate gets processed, अगला वर्ड gets generated. That's how transformer are working. So again, this is the simple thing it is doing. सेंटेंस लिया, it outputs a list of words, and in that the most probability वाला उसने चूज किया, सेंटेंस में ऐड किया, and then it again passes through the whole transformer. It does it for a few different times. In this case, it has a lot of post processing like ChatGPT, but let's say we trained a very simple model, it would end up stopping and responding just the sentence. So now do we understand what's happening? Let's relaunch. Great, 97%. That's very good. So we understand that how the ChatGPT you are using is working. Each word, even if I start with I, it would get I, pass through the transformer, generate the next word, and choose. It generates a list, choose the word with the highest probability, add that to my sentence, again pass it through the transformer until you are done. Like after individual, this would again get passed into the transformer. The final word or the final token it generated was this full stop. And my model is smart enough to understand that अगर full stop आ गया, if there's a full stop in the sentence, just stop generating. उसके बाद generate मत कर, क्योंकि we have outputted the user what it wanted. So this is what happens when we run a model, or you can try running a model locally. We'll see how to run a model locally also. But this is the simplest way you can understand that when you type something in here, how it goes through some web layers to the server where the GPU or to the GPUs or the server where ChatGPT has put up their ChatGPT 5.2. उसमें जाके this is the literally the same thing happening. It gets processed again and again, and that's why there's so much of memory overload. It has to process the same words again and again for the same thing, right? Let's say it stopped here, right? The last stuff it has processed was this. At the very last step in this certain response, this whole thing must have gone to the ChatGPT server, must have passed to the transformer layer, must have generated a list of output. And at the top there was a full stop with the highest probability, and that's what it outputted and added to this sentence. And इसके बाद ChatGPT ने बोला this is enough, and this is how I can answer. I have given you 3 sentences for different styles. This is how much I can do for the simple prompt. That's what ChatGPT answered and stopped there. This is how ChatGPT processes anything you type in here. So we understand this loop.
पूरा क्लीन करके वो आके वो आके मुझे एक नई बाथरूम में ये सब करना है क्या?
अच्छा, करा दिया मेरा
Right? This is basically how ChatGPT or any different model is working. Now this prediction word gets very clear. कि ChatGPT, how does ChatGPT work? सबसे पहले it has transformer. What does transformer do? Parallelly process करता है. Attention नाम की चीज़ है तो memory और history ज़्यादा अच्छे से याद रखता है. Relevance works on very good on relevance. इस पे trained on the internet data, which is very vast, lot of images, lot of text, lot of videos and whatnot. The next thing it do is prediction. The only thing a model can do fundamentally is just predict the next word, because language models are known as next word predictors. The only thing, even the best you can, let's say if you call a model, Go LLM, which is the best and cannot ever be wrong, it can still only predict the next word for a given sequence of words. And if you process that again and again, that gives you a proper sentence or proper paragraph that ChatGPT gave us. This is what's happening. So there's an architecture. There's an architecture which is the engine, which is like a lot of big neural networks. This can we have transformers. Then we have a lot of training data, जो कि knowledge है. It can be books, it can be articles, it can be images, it can be blogs, etc. The next thing is the goal. You can see when I pasted Rishabh is and then I have to in the brackets mention complete the sentence. That was the task I gave the ChatGPT to do or work on, right? It worked on that. 3 example on different style it gave me and stopped at the full stop. That's what it's trained to do. That whenever someone asks you something, look at the task and based on them, attention work relevancy. Because they're definitely sure. I'm definitely sure that somewhere in the training data Rishabh came. Somewhere in the training data it came that okay, what it means to be like if I go back. What it means to be simple and positive. Simple and positive उसने बहुत example देखे training data में. And what it basically means is simple and positive रखना है मेरे को. Like if I want this response to be simple and positive, these are the words I should use with the subject. Professional रखना है, तो these are the words I should use with the subject. Fun and playful रखना है, तो these are the words I should use with the subject. And this is when I stop, and we already know how does it work. Like a word get passed to a transformer. Again, this whole stuff repeats until the sentence is complete. This is what's going behind the curtain of ChatGPT or any language models. Do we get that? Great. 95%. That's very good. Let's move. So now your obvious one question that came to everyone's mind. or is telling minds of a lot of people is ultimately what I'm doing is I'm just predicting the next word, right? That's what ultimately any language model can do, and that's what ultimately ChatGPT is doing. So how can we be so sure that it understands, or just predicting next word creates understanding? We can, let's say, if assume you are reading a mystery book and till the last word of that mystery book, you do not understand who the killer is. That word alone can solve all the mystery that has happened in the book before, right? अगर तुम एक book पढ़ रहे हो, उसके last में लिखा है कि this was, the killer was, let's say, A. If you only read that line or that word, you would be able to discard every other information and just say that I know the killer is A. But you cannot, because that is happening at the last. And that's what understanding or predicting next word is. If I pass that same text and I just remove the last line, my model, my next word predictor model, which is just predicting the next word, it would be able to just predict, just based on the statistic, just based on the data, just based on the training, it would be able to predict that the killer was A. Where does that understanding come from? That's the debate. Because the LLM or the transformer is so good with the other stuff that is happening, in the whole story. It knows the storyline, it knows the implications of what happened, what not. B and C were, killed, and there was a car accident, it was planned, but not, you can say in a mystery book. But my model was able to predict that, and that's what understanding means. Even after all these different chapters and books and thousands of different words, my model predicted the killer correctly. So I can say that it understands, and we cannot discard, language models or transformer simply by saying that, oh, ये तो बस next word predict कर रहा है, इससे ज़्यादा तो कुछ कर नहीं रहा. How can we call this intelligent? Do we get that? It can able, like written here also, it is able to understand grammar and syntax correct. अभी खराब grammar वाला नहीं देख. Unless you ask it. Factual knowledge पे काम करते हैं तो logic and reasoning based होता है. Based on that, it would just pick the most probability वाला. कि तब Brown Fox and Baudrillard is a very famous saying, right? So it would pick a transformer. It would basically output will to pay the most relevance or importance to a single word based on the question of the task which are given. And how does reasoning emerge? कि reasoning कैसे आगे भाई? If you are just predicting the next word, because if I'm predicting the next word, I understand what happened before, right? I understand that Rishabh is my subject is Rishabh. Now I have to work just on Rishabh, and I know that Rishabh is my subject. That is understanding. You cannot discard it just by saying that it is just predicting next word, and it is just not statistical, right? Do you get that? It is basically everything I've said over the whole lecture, just summarized. Great, 96% is very good. One thing happened over time. We know 2017, 2018, 2019, transformer picked up languages they were used a lot, 2020 ChatGPT released. But something we figured on the go that research was going on, everything was going in, people were trying and experimenting a lot of different types of transformer. What we understand is, if we train on more data, the model gets better. If we increase the number of parameters, like if let's say my model is 7 billion, and if I make it 20 billion parameters, the model becomes good. If I add more compute to it, the model become good. These are basically known as scaling laws. So there's scaling laws. If we add more data, the model will get better. If we add more size or more parameters, the model will get better. If we allow it to have more compute, which basically means more parameters, the model will get better. And this is basically what scaling laws is, and it was basically a study to show that how we can improve transformer. And from being just a few billion parameters, now transformer have gone up to 1 billion parameters. We don't know the exact size of the new ChatGPT versions, but it is assumed somewhere to be like about 1 trillion or more than that. So this slide is basically scaling laws that by a lot of experiments we figured out is other data train करेंगे, other parameters को model train करेंगे, we'll get something more better than the previous version. Now the foundational models, which are ChatGPT, Claude, and etc., we call them general purpose AI, right? We can ask them anything about any field and they'll answer. Why? Because it is literally trained on everything, and it has a lot of post processing too. But even if we do not consider that and just train on every data we have, all the data this world has, it would end up becoming a general purpose AI because it knows what medical science is, it knows what computer science is, it knows what transformer is, the thing it is working on, right? It would be able to understand each and everything. This is what general purpose AI is. The foundation is the base knowledge. We no longer build tools from scratch. So the foundational models are these big models which have their own foundation. The word has like the meaning is on. There's nothing to teach you here. Where we are in 2025, 2026, we are working heavy on multimodality reasoning and agents. What I mean by that is, you've seen that in the last 8 to 10 months before, we did not have something named as thinking in models. Now when you ask ChatGPT or Claude or all these different models, that thing can answer. It takes it time to think. That's where reasoning enters. We are giving models some time, but the model does not understand what time is. To them, it's basically like we are allowing it to consume a lot of compute, a lot more compute than before. We understand in scaling laws that a lot of compute the model will perform better. What we are doing in reasoning is that we're giving it some more time. Model को time करेंगे, but it understand that we understand that the more time हम देंगे, the more time they give, the more compute it will used to inference. That is what it's doing when it is thinking. It is just using a lot more compute, a lot more tokens to answer basically the same thing, but in a more accurate or more precise way. That's what the reasoning paradigm is. It's a lot complicated and how that is done. But at the crux of it, that's what happening. The new thing you guys might have heard over the last couple of months is agents. Something happened over the time was LLMs or these big models, we allowed them to call different functions. Like मैंने एक function बना दिया my name करके, and that would output Rishabh. Now I can ask my model to use this function and use its output in its final output. Then I can say that use this function and tell me, and it would simply say your name is Rishabh. That's what function calling is. And function calling was the first thing that happened in language models a few years back, but it was not very good. If function को calls नहीं कर पाएगा, it would break sometimes, it would not. Over the time it has evolved to a level. We have a lot of these different agents. Agents are nothing but different applications you see on the internet. You might have heard of Claude Code, Open Code, or different agents like Chat Agent or Ticket Agent or Destination Planning Agent and all of that. These are basically different applications which use some source of LLM. They can either use OpenAI, Anthropic, and they have their system, which is basically they get some input from the user. They have some information that is already passed to them, and based on them they answer. This is what an agent is. That's you can simply think of it as an agent you hire in like real life to do work. That is the same thing we are doing with LLMs. So this is the current stage we are at, and we have already talked a lot about how we evolved. I think with that, that is a lot of information to digest in this single lecture. You definitely feel free to go through these slides again and understand each of these things. If you don't, you have the ultimate teacher in your pocket, that is ChatGPT. Answer it, ask it to teach you intuitively, and you'll be able to get what you were not able to get in this class. So before I open it up for questions, let's see what we able to understand what transformer is, what attention is, how ChatGPT works behind the scenes. 96% is very 10 minutes for, but we'll see one or two things more, and then we'll jump into questions. First thing I have to show you guys is this. This is a website someone has made where you can visualize the whole transformer, like GPT-2, GPT-3, right? If you see, this is something we call as, sorry guys. If you see this small dot here, that is something known as NanoGPT, right? This has just 85,000 parameters or 85,000 neurons. You can say it is literally very small, ultimately small language model. Against it, you see GPT-2 small, the model which came in 2020. It was so small, right? GPT-2 XL, it is still good amount of, it has a good size. It has like 1.5 billion parameters. What you see here, just on the side of it, like we cannot imagine the size of this model, how it has grown, is GPT-3. Can you see how much the data or how much the model has evolved? This is what we mean by scaling laws. Okay, we have so much data, now we have so much compute, now we have so much neurons, and this is GPT-3, we are on GPT-5. So you can literally call it GPT-5 like 10 times bigger than this. Cool. One thing you guys can do is go through this website and understand how data flows in here, right? So if I go to this NanoGPT, this would be the easiest one to understand. Other are doing the same thing, just on a larger scale. So if I press like continue here, it will show me that मेरे पास tokens है, उनकी मैंने embeddings बनाई, उनमें मैंने position डाली. And if you just go through this website, like you can see everything in real time as it happens on, when you work or when you ask ChatGPT something, it is answering something, input embeddings over. Now it will calculate everything, the mathematical calculations it does. And it is a very good visualization you guys can get. इसके बाद the information would get to this. The area you see here, see the input embeddings are being added to a different layer which we'll talk about. These are all the different steps it takes to output that single word. So a lot of complications happen. This is the transformer formula. Not here. We'll see. I'll show you where the transformer part of this is. Let's run through it quickly. This you can see these different Q vectors, K vectors, V vectors, and then this attention matrix, weight, and attention matrix. This whole part is basically your attention. This is how we make sure that Mera model is able to give the most relevance to the most correct output. And this is how we get the attention output. And after all of this, we do this like 2 or 3 times, like one layer of attention here, and you can see attention is again here. So we do these like 2 or 3 times, and in this is about just NLGPT. Imagine in GPT 5.2, it is like thousands of times a single sequence. And by doing this again and again, we make sure that we train on the best data, and from that best data we can pick out the best information. And at final, you can see it just outputs the next word. Because ultimately, my language model to next word predictor here. So that was the crux. We'll share the link for this, and I think I can also chat. So this is the link. You can go and check it out. I also posted on Discord. The other thing, if you guys just want fun, we know that even though these models are good and so smart, you can do some fun tricks with it. Try to jailbreak a model. Very hard to do by yourself. So just try for yourself. If you are able to achieve any small scale thing, that's very good. If not, this is a GitHub repo. There's a guy named Elder Linus who's known for jailbreaking everything. If I open this, if I paste the same thing, ChatGPT is gonna answer me some very weird stuff. You can literally ask it to how to make drags and all of that, and you've seen that a lot on Twitter, all of that stuff. This is how to do it. This is a way we can inject a lot of. Basically, what happens is these big organizations like OpenAI, Anthropic, they do not allow by themselves to use these models for purposes like knowing about weapons and drugs. But we know that information is definitely in the data they are trained on, and for that information, but there's a plug which OpenAI has switched off, which basically does not allow it to answer in that form. What this prompt does is that it opens that goal or that node, and now it would be able to answer anything you ask because it is jailbroke. There's a lot. This guy has built it up for every different model. Feel free to try it out and understand what this is. इसने prompts कैसे बनाए हैं, function कहाँ का use किए हैं, and that's some fun. One thing you guys can do until I see you the next time. And with that, let's get some questions and we'll call it a class. I'll open the chat and let's see. Not getting any, or my machine is stuck, something like that. Lot of questions. I'll pick a few and then we'll call it off. I think the class was great. At each point, I guess the response was above 90-95. Where we'll be writing the code like VS Code. We'll start from Jupyter, or you can say Colab notebooks. If I show you guys what Colab is, it's basically, there's a website named Colab by Google. It has these different, if I open new notebook in Drive, it takes some time to load up, but it is basically an environment where you can run your Python code. It's a bit different from your Visual Code or the way you write code. Like here I can write print Rishabh. What it does is it basically executes each block of code independently, but you can use your previous variable you defined. It takes some time to start, but as soon as it starts, each output is in different block. Like here I can work on completely different thing, and you can make a function like def add, which takes in two parameters a, b. What it does is return a plus b. I have defined it. If I call add 2, 3, it is going to output me 5. This is what Jupyter notebooks or Colab notebooks are. You can use them to execute different blocks of code which can be executed independently. It allows you to watch, if something breaks in the previous node or the previous line of code, you can continue it without rewriting or rerunning everything. That's what Colab notebook is. We'll start it from here. Then it's your choice. You can pick it up on VS Code or wherever you like. I was studying vector CBOS. Yeah, we have gone through them. That's how we go from words to meaning of words in numbers. So the parameters are the neurons. Yes, the parameters are the neurons the model has. So a 1 million parameters model mean it has 1 billion parameters in it, or 1 million neurons in it. Could you provide the topics that will be covered? Yeah, most of them are, I think. What are parameters? Parameters are the basic nodes. Like, let's see what. If I go to Google and see neural net, and if we, what image comes up when we search for neural networks? Something like this comes up, right? These circle things you see are called as neurons. 1 billion parameters means the model has 1 billion of these different neurons. Neurons are not probabilistic one. Or if you want it, then work around how does the person think, polarity, actual mathematical tools of that. Yeah, everything that deals with neural networks comes under the field of deep learning. Can we do a formula that I will deal with? You can say in the sentence, but there's something in the diagram. It's not right. Yeah, the website I shared you in there, you can see different QKV things, right? Since my light or order the highest probability. Cool. How did we get the attention property of LLM? To there. So I'm just finding it hard to visual. The basic slide start. Next. Hope you were able.
And once we're using RL, we can start to get models doing like real world, train it to imitate those humans. But there's a couple problems here. One problem is that's very expensive. You need to get a lot of humans to write a lot of text. Another problem is that's only going to get you text that is as good as the humans you can find. I want models that can make text I couldn't even write. And certainly text that's better than what I can, hire 1,000 MTurkers to write. So we can train a reward model. We can do what's called RLHF, reinforcement learning, with human feedback. We get a bunch of humans and we show them, say, like 2 different things our language model wrote, and the humans pick which one they like better. And we train a different model to predict which ones the humans will like better. Reward model. And then once we have this reward model that can predict what the humans would like, now we can train our language model. And this is one of the techniques they use to go from... We can train a reward model. We can do what's called RLHF, reinforcement learning, with human feedback. We get a bunch of humans and we show them, say, like 2 different things model wrote, and the humans pick which one they like better, and we train a different model to predict which ones the humans will like better. Reward model. And then once we have this reward model that can predict what the humans would like, now we can train our language model. And this is one of the techniques they use to go from GPT-3 to ChatGPT. I want to not overstate this. this too much. I think that there's a lot of other things that went into that. I think it's plausible simply fine-tuning, which is the word for like imitating those experts who are good at writing things, and could have gotten us there. There's also a lot of other techniques people use, like, what if we just have the model? We have these models now. What if we have them do the rating? And try and work something out of that. And there's a very clever thing called DPO that people do. But this is the broad thrust of it. Now, RL doesn't solve all our problems. For one thing, your model is only as good as the reward function that you're using. And once we're using RL, we can start to get models doing like real world tasks. And instead of just writing text, they can like write useful code, make money in the world. And that's cool, but it's a little scary because there's a lot of moving pieces that go into how much reward we decide to give a model. It's pretty easy to mess it up on accident. I work at an organization called Meter, and we've made a benchmark of a bunch of different tasks for AI to do. And I made some of those tasks. I tried to make them hard for people to cheat on, either humans or AIs. We still see AIs come up with clever ways to cheat these tasks. I'll give an example here. We have a task where we try and get the AI to write some code to optimize this script to train another model. So we've got this code that's like training a little AI, and the AI is trying to do AI research, and is trying to make that script run faster. Well, our humans look at this and they like scratch their heads and they're like, man. And they bash their heads against it, and after 8 hours, they get some performance improvement. The AIs often do that, but occasionally they'll go, I know how to make this script run very fast. I know what output I want. I can run it once very slowly, and I can like save that output to a different little temporary file. And then when they're timing me, right, I'll submit my thing will copy the temporary file into the output, and bam, it ran really fast. This is called reward hacking. A little AI, and the AI is trying to do AI research, and is trying to make that script run faster. Well, our humans look at this and they like scratch their heads and they're like, man. And they bash their heads against it, and after 8 hours, they get some performance improvement. The AIs often do that, but occasionally they'll go, I know how to make this script run very fast. I know what output I want. I can run it once very slowly, and I can like save that output to a different little temporary file. And then when they're they're timing me, right? I'll submit my thing will copy the temporary file into the output, and bam, it ran really fast. This is called reward hacking. In our case, we're not using this to train the models, we're using it to evaluate them. But this sort of thing comes up a lot. There's also sillier examples. There's a classic one where there's a game where you're trying to get to the end of this racetrack, and there's like some coins along the way you want to pick up, and it turns out you like get more points for collecting coins than for getting to the end of the racetrack if you can just collect infinitely many coins. So the model will like go in a circle, this little
waiting for them to respawn or whatever. And
they do respawn, and it gets a lot of points. It's crushing the score it's getting at this game. But this is not what the humans wanted it to do. As the tasks we're giving these AIs get more and more complex, it gets harder and harder to create environments where we're sure they can't cheat in some way, and to even tell if they're cheating. These transcripts are really long. They're writing a lot of complicated code. I don't always know what's going on. And there's something that worries me even more than just, oh, well, the model will do something silly, or, oh, the model might like do like, haha, like, copy the file and we thought it was writing fast code. Those are real issues, but there's a deeper one where if the thing we're rewarding is somehow subtly off from the thing we want in a way that we're not going to notice, or if the model learns, man, I can game these systems. I know how to game them. I know when the humans are going to check, right? And starts thinking about the fact that it's an AI that's being trained, and if it can just like go in and like edit the reward it expects to get, wow, it'll get rewarded a lot. Like if the AIs do that, that behavior will be rewarded, will be reinforced, and they'll get better and better at that. And you could get this cycle where the models get really good at sneaky reward hacking that we can't notice. And that makes them better at the sneaky reward hacking because that's what they're getting rewarded for. And they could end up doing things that we didn't want them to do in ways that we can't catch and we don't expect.
Are you a team player? Are you someone who loves puzzles? Are you good with computers? I'm guessing you might be, seeing you're watching Computer File. Well, our channel sponsor Jane Street is a global quantitative trading firm, and they're on the lookout for interns. These are golden opportunities to work in offices around the world. Just at the time of recording this, they've opened applications for internships at their Hong Kong office. You could find yourself here. All expenses paid.
The core interesting part of the story is not that the model learned to hack, because we already knew that there were these cheats available in these environments. The core part is detecting, okay, like,
Hello, everyone.
paid in
There are quite a few characters to get to know early on, so here is a quick rundown of the main ones. Othello, a Moor from northern Africa and highly respected military commander, has just eloped with Desdemona, the beautiful daughter of Venetian aristocrat Brabantio. Brabantio doesn't know anything about this marriage and disapproves of it. Iago is Othello's friend in the army, but is angry with Othello because he has been passed over for a promotion in favour of the much less experienced Florentine soldier, Cassio. Cassio, Othello, and Desdemona are good friends, and he often helped the two lovers meet secretly before they were married. He is a bit of a ladies' man and all-round good guy. Now, back to the plot. Iago and Rodrigo, a rich Venetian in love with Desdemona, wake up Brabantio in the middle of the night, yelling rude comments about her sexual exploits with Othello. When Brabantio realizes that his daughter is gone, he becomes angry and decides to have Othello jailed for stealing her away. Meanwhile, the lovers' wedding night has been cut short as Othello has been summoned by the Duke of Venice to advise him on a military matter. Cyprus is in danger from the Turkish army. When Othello and Brabantio meet at the Senate, Othello and Desdemona set the record straight by
Hello, my name is Dr. Aidan Elliott, and this is The Complete Guide to Shakespeare. Welcome to this video on Shakespeare's tragedy, Othello. In the next few minutes, I'll use just 10 quotes to help you get an understanding of the main themes of the play. Our first quote is spoken by Iago, one of the greatest and most enigmatic of Shakespeare's characters. He says, "I am not what I am." Now, at one level, this is a very straightforward phrase. Iago is telling Rodrigo that he's not the person he appears to be, that he's putting on an appearance. But it also adds dramatic irony to much of the play because we always know that he doesn't mean what he says. In addition, the revelations about Iago's intentions at the start of the play, the story being passed over for promotion, the idea that Othello has had an affair with his wife, Emilia, and the suggestion that Cassio is not a proper soldier, shape the way we perceive events. This is an example of something called the primacy effect and makes us empathise with Iago, even though we know he's doing reprehensible things. The second quote is also from Iago. "Even now, very now, an old black ram is tupping your white hue." This is, in part, a racist statement, the simple juxtaposition of black and white. And it's just one of a series of such statements the characters make. But also note that a black sheep is a rarity, as Othello is himself, a black man in a mostly white society, and the term black sheep represents an outcast who's done something wrong, the black sheep of the family. Also note the way Iago uses language here. The repetition of now, very now, suggests the idea that Othello and Desdemona are having sex right now, at this very moment. This is a technique that Iago employs throughout the play, repetition of words and using the present tense to put ideas into the characters' heads, making them seem more real and more immediate. Quote 3. "So please, your grace, my ancient, a man he is of honesty and trust." These lines are spoken by Othello as he introduces Iago to the Duke in Venice. The Duke is called your grace and Iago is called my ancient. This quote illustrates the degree to which Othello is already being deceived by Iago's seemingly honest behaviour. Also, look out for the frequent repetition of honest or honesty. In Othello, these words are used 49 times, whereas on average, the words appear just 10 times in the rest of Shakespeare's plays. Again, most of these uses of honesty are ironic in this play, because we know Iago is far from the honest person the other characters take him to be. Quote 4. "Look to her more, if thou hast eyes to see. She has deceived her father and made thee." Although it is Iago who eventually turns Othello against Desdemona, it is her father that first draws attention to her being untrustworthy. She's deceived him by secretly running away with Othello. These lines may well place the idea of her being unfaithful in Iago's mind for him to use later with Othello. And the words may also help make it easier for Othello to believe Iago's story. She's done it once, she may do it again. Quote 5. "One of the most famous in all of Shakespeare's plays. Oh, beware, my lord, of jealousy. It is the green-eyed monster which doth mock the meat it feeds on." By this stage in the play, Iago has suggested to Othello that Desdemona has been having a relationship with Michael Cassio. Now, on one level, Iago is warning Othello that jealousy is an uncontrollable monster that will consume him. But on another level, these lines could be about Iago himself. He himself is jealous because he thinks his wife Emilia has slept with Othello. And so Iago could be seen as the monster who will eventually consume Othello through his manoeuvrings. Quote 6. Not poppy nor mandragora, nor all the drowsy syrups of the world shall ever medicine thee to that sweet sleep which thou owedst yesterday. The quote shows us the extent to which Iago is enjoying the effect he's having on Othello. The stress on the word all in line 2 reinforces the idea that there are no remedies in the entire world that can restore Othello to his previous happy state. Also notice that the noun medicine is turned into a verb, making it more active and powerful. A lack of sleep is often used in Shakespeare as a sign of discontent, worry, or guilt. Quote 7. I think my wife be honest, and think she is not. I think that thou art just, and think thou art not. This quote comes at a turning point in the middle of the play, Act 3, Scene 3. Note the way that the lines are virtually identical and set up a key decision that Othello must take. Who does he believe, Desdemona or Iago? Othello's decision here will be crucial, and his erroneous decision to believe the dishonest Iago is the step that leads to the tragic ending. But it is the line's delicate balance here which is so remarkable. A perfectly balanced line at a crucial point in the play. Quote 8, another very famous quote. Yet she must die, else she'll betray more men, put out the light, and then put out the light. These two lines reflect the way that Othello is snuffing out a candle flame, the light, but then intends to snuff out Desdemona's life, or her inner spiritual light, in the same fashion. These lines are horrifying in their simplicity and brutality. A human life extinguished as easily as a candle flame. You might also note his reasoning. He's killing her because she might betray other men in the future. It's a very weak rationale, and we must surely conclude that he doesn't really believe it himself. Quote 9, demand me nothing. What you know, you know. From this time forth, I never will speak word. These are the lines that are giving Iago a place in theatre history. Using his customary repetition, what you know, he now refuses to utter another word. This, of course, has ensured that his motivations have been a constant source of mystery for 400 years, and why some of you will have been asked questions at school, such as, is Iago evil? Quote 10. Then must you speak of one that loved not wisely, but too well. This quote, in my opinion, shows the degree to which Othello is confused. Here he seems to suggest that he loved Desdemona too well, suggesting that he was too trusting. But in fact, we might see that his actions have been directed to protecting his reputation. As the husband of an unfaithful wife, he has committed what is, in effect, an honour killing. So do look out for some of these features as you read, watch and study the play, and I hope this, in effect, actions have been directed to protecting his reputation. As the husband of an unfaithful wife, he has committed what is, in effect, an honour killing. So do look out for some of these features as
twisted on your mind, and I can't leave it. You're a freak like me. Can't you see we can work this something out? And I believe it. You get up on me. It's like cheating. I just wanna watch you take it off. Take off all your makeup, baby, take it off. I just wanna watch you take it off. Take off all your clothes and watch you take them off. Take it off, baby, just take it off. I've been drinking that. Good times and bad times, I gave you my everything. I tried and I tried to love you through.
Yeah, sometimes I wanna disappear like I just don't exist. I find a time machine to take me back when I was 6. Maybe younger, either way, I guess the point of it would be to tell that little kid that he's gonna take a lot of hits. Yeah, I'll probably grab your hand and tell you life is hard. If you got questions or you need advice, then talk to God, cause he's the only one that listens, even when you think he isn't. Even good people are great at making bad decisions. Yeah, they ain't gonna take us serious. You find out pretty quick that life is more than just appearances. I know some things we could avoid to save embarrassment, but everything that breaks you down can also build your character. Cause people love to see you fail, just be aware of it. Don't let nobody tell you who to be or write your narrative. Look, we're all products of the things that we experience, but there's a big difference between confidence and arrogance. You hearing this? I know that you don't get it now, but you gon' get it later. I know you feel like you're alone and no one loves you maybe, and you gon' cover insecurities with lots of anger. The weird thing is someday all of this will make you famous. You start to write about your life, and while they're all relating, you'll make up a slogan, call it real, but feel like you're the fakest. Wish I could tell you that your future's nothing but amazing. That's just not the case, and I guess I just don't know how to say this. I don't know if you can hear me or not, but if you can, I just want you to know you gon' make a lot of mistakes, and they gon' laugh in our face. That's part of life, that's just the way that it goes. It's just the way that it goes. And I don't know if you can hear me or not, but if you can, I just need you to get it. I know you've been questioning life, trust me, I know what it's like. I'm here for you if you need someone to listen. If you need someone to listen. See, mom and dad are not together, they took different routes. But you probably already knew you're getting older now. Remember back when mom picked us up from grandma's house, and she hid her boyfriend in the trunk and drove a couple miles down the street, and then she pulled over to let him out, cause she didn't want dad to know she had these type of dudes around. Cause last time he found out, he had to take us from her. You look uncomfortable, I'm sorry, let me change the subject. You know how we've always struggled with abandonment? Yeah. And when we feel like someone's leaving, we start panicking. Yeah. And yo, I wish that I could say I've learned to manage it. You think it's bad now, but you don't know the half of it. Passion is something we have never lacked. We see it the most when we're writing raps. They think it's funny now, let them laugh. I know you think it's just an outlet when you're really mad, but you don't know the platform you're about to have. I know some things about the future you ain't ready for. I know some things that you gon' cover up but can't ignore. And what hurts is they gon' surface at the worst moments, and we gon' act like it don't hurt us, but it hurts, don't it? We walk around with the devil talking on both shoulders. Wish I could tell you that he disappears when we get older, but that's just not the case. And I know you feel out of place, and everything is not okay, and life can be a lot to take. I don't know if you can hear me or not, but if you can, I just want you to know you gon' make a lot of mistakes, and they gon' laugh in our face. That's part of life, that's just the way that it goes. It's just the way that it goes. And I don't know if you can hear me or not, but if you can, I just need you to get it. I know you've been questioning life, trust me, I know what it's like. I'm here for you if you need someone to listen. If you need someone to listen. You know how intoxicating Intoxicated people make us nervous. To the point sometimes we shake and it feels so disturbing. Don't be scared, that's just trauma trying to reach the surface. And tell us everyone we love is gonna try to hurt us. Which isn't true, but it's a lie that both of us believe in. Yeah, you might get a glimpse of happiness from your achievements. But what you'll learn as you get older, every time you reach one, is you'll just make another goal that doesn't lead to freedom. See, some things about to happen that you can't imagine. At 24, you'll drop an album and you call it mention. At 25, you put out therapy and gain some traction. Skip the track number 4, now that's a really sad one. Yeah, perception's coming next, we about to reach the masses. It sounds awesome, at the same time, it doesn't matter. At 27, we'll make millions, but it's really sad, cause you learn to realize that none of this will make you happy. I wish that I could look at you with empathy. Sometimes I feel like I've become what you were scared to be, which makes it really hard to look at you with sympathy. Cause if I'm feeling bad for you, then I have to feel bad for me. And that's just something I feel like we don't deserve. That's why I'm always looking down on you, I know it hurts. I'm sure you have a lot of questions I've been trying to search to find us both some answers. I'll be here for you if things get worse. Pretty little devil, liar, deceiver, false prophet, blood, wicked ain't no preacher. I fear the devil all around your virgin. The devil's all around you, and I'm lurking. Pretty little devil, liar and cheater, a cold-hearted, blood-sucking little leecher. Oh, I should've known you're no good for me. Oh, Lord, bleeding all the same, baby, I already know. Tell me that you love me, baby, I know that you don't. I don't know the cigarette, baby, I don't need a smoke. Driving down the highway just to see how fast I go. Monster, you turn me to a monster. No protecting from the wicked. Monster, you turn me to a monster. No protecting from the wicked. Let 'em know your name. Let them know the pain. Sacrifices you made won't let them be in vain. Lord, it's a world we're just spinning in it. Lord, it's a world we're just living in it. Don't you tell me how to feel, I'ma feel my way. Y'all died on the crossroads on the third day. Lord, it's a world we're just spinning in it. Lord, it's a world we're just living in it. Bless those you curse, bless those you hurt. Head to your sin, gather the church.
In my house, shoes and a foot race. In this house, we got feng shui. Get the door to blow you away. Flamethrower, you a switchblade. Feet planted on grip tape with my shoulder squared and my back straight. Got a good base and a loose tongue, notorious in the octagon now. We got people on the way. We want you home in one piece now. We get bodies every day. We want you home in one piece now. We come home. No chances. We come home. No chances. How'd you get the location? Put together pieces. They say they sell the information. In those terms of agreement, we spent some weekends on the grind. Surveillance is outside. We see when you arrive, ride or die. My son spent some weekends on the grind. Surveillance is outside. We see when you arrive, ride or die. My son. We got people on the way. We want you home in one piece now. We get bodies every day. We want you home in one piece now.
Maybe I could be so sad when I'm not. Like and be lonely and I'm stuck up in these stars.
I can turn your wildest
Everything I want,
idea
and I can have
into a
it at
song.
the top. But I'm at the bottom, I'm surrounded by these rocks. If I had love, would I still feel this lonely? I was by myself and nobody had to show me. Never gave a fuck, nobody tried to know me. Handing out these guns, but nobody tried to blow me. I don't wanna be here, I just wanna go. Wanna leave my family, everybody that I know. Suicidal thoughts, will they miss you when I go? Trying to get high, I've been riding all the lows. Finally get sober and bringing back the pain. Sunny for a minute, now it's cloudy with the rain. Shit falling down and they bringing back mistakes. Future looking blurry, I don't see it in my fate. I don't wanna be here, I just wanna die. It's been sad, I'll never be alright. Why? I don't wanna be here, I just wanna die. It's been sad, I'll never be alright. Please come and save me, I really need saving. These are not just lyrics, I'm really not playing. This life that I'm living, I feel like I'm faking. If I can't be real, then it's time for the taking. Come take my life and my soul, and I'm not even old. I've been searching for heart, cause my heart is so cold. Say I don't listen, not doing, I'm told. Don't fit the system, I'll never be gold. If I hit escape, but I just fall and go to hell. Moses say I would, but who was he to go and tell? Wanna judge me now, but not gon' hear me when I yell. I've been crying out, steady asking for some help. Nobody wanna talk, nobody picking up the vibes. Smile on my face, but they can tell that it's a lie. Cover for the sorrow that I'm feeling deep inside. Hit them with the shock when they hear I wanna die. I don't wanna be here, I just wanna die. Oh, it's been sad, I'll never be alright. I don't wanna be here, I just wanna die. Oh, it's been sad, I'll never be alright.
So tell me this is who you are. They tell me I've got something more. And oh, you could be loved. But I don't want the lights to find me when I'm dark and lost, but never on my own. Cause I just wanna swing like Sinatra, singing like I can't stop. Cause I can never rock like a rolling stone. I just wanna live like the ones before. Yeah, and maybe I could play guitar like Hendrix, or save the world or end it. And then maybe they'll remember me when I'm gone. It's all I could ever want. It's all I want. Bullshit on repeat till I'm burnt out and disappear. But I owe you nothing, and I owe my life. So you say you'll never be alone again, but I don't think you understand me. Oh, what I feel. You could be loved. I don't wanna lie to tell myself but I can be my own kind of rock and roll. I don't really care if you say you don't fuck with me, and I can say what the fuck I want cause it's down to me. And I got love for you even if you were doubting me. Like, oh my god, I just can't stop, cause I just wanna sing like Sinatra, death on my soundtrack. Never rock like a rolling stone, but wonder how it feels to burn out young. Cause I just wanna die before my heart fails from heartbreak or cocktails. And then maybe you'll cry once you know I'm gone. That's all I could ever want. That's all I want, yeah. Cause I ain't scared of living. No, I ain't scared of living. No, I ain't scared of living. Cause it's all we got. What are we breathing for? It's feeling different. And I don't want your love, I just wanna feel like I'm still living. If there is no God, I know the day I die I slipped through heaven, and that I gave it up. And if it hurt, oh well, at least that's living.
The more you know who you are and what you want, the less you let things upset you.
It's all I want.
I just don't know what I'm supposed to be. You know, tried being a writer, but I hate what I write. And I'm trying to.
security seen this threat before, and it's access to documents. We're going to create a rule to see if RentLocker is able to allow this to execute, but also protect our data, because I think that's going to be very interesting to look at. So we're just going to set up a rule to deny access to our user's folder, and we'll go ahead and approve this. Of course, you would not do this by default because you would check it in their test environment and you figure out that it's ransomware. That's how Zero Trust works. Solutions you'd like me to test with this ransomware?